Okay, so we're going to show that points A, which is the point 1 comma 1 plus D, B, which is the point 3 comma 3 plus D, and C, which is the point 6 comma 6 plus D, are collinear by showing that the distance between A and B plus the distance between B and C is equal to the distance between A and C. So we're using the segment addition postulate to prove that these 3 points are collinear, meaning they're on the same line. Okay, so remember, if you have a point, right? So let's say we have a point at the distance between x1, y1, and x2, y2. Remember, uh, this is equal to the square root of x1 minus x2 squared plus y1 minus y2 squared. Remember, this is the distance formula for the r by r coordinate plane, right? Okay, so we're going to use this in order to show this. So let's go ahead and start our proof. So we're going to find the distance between A and B, then find the distance between B and C, and then find the distance between A and C, and see if the sum of these two is actually equal to the distance between A and C. Okay, so let's go ahead and get started. So the distance between A and B is equal to the distance between the point 1, comma 1 plus D, and the other point 3 comma 3 plus D, right? And then this is equal to the square root, so a long square root. Let me fix that a little bit. So the square root. So this is going to be the difference between these, so 1 minus 3 squared plus, so this is going to be 1 plus D minus 3 plus D squared, right? All right, well, this is equal to, so 1 minus 3 squared is just negative 2 squared. And then we have d minus d, so the d's cancel, and we're going to be left with 1 minus 3 over here as well. So this will be negative 2 squared as well. Okay, so this will give us the square root of 4 plus 4, which is equal to the square root of 8, which we can reduce this a little bit better. This is the same thing as the square root of 4 times the square root of 2, and this is equal to 2 square roots of 2. Okay, so we know the distance between A and B is equal to 2 times the square root of 2. Let's go ahead and find the distance between B and C. So the distance between B and C is equal to, let me write this first. The distance, so the point B is 3 plus D, 3 comma 3 plus D, and C is the point 6 comma 6 plus D. 6 comma 6 plus D. So this is equal to, so a long square root again. So this will be 3 minus 6 squared, right? 3 minus 6 squared plus 3 plus D minus 6 plus D squared, right? Okay, so this is going to be negative 3 here. So this will be the square root of negative 3 squared. And then d minus d, the d's go away, and then we're left with just 3 minus 6 over here as well. So plus negative 3 squared again, right? And this is equal to, so negative 3 squared is 9. So 9 plus 9 is equal to the square root of 18. We can reduce this to the square root of 9 times the square root of 2. And this, of course, will be 3 square roots of 2. So we know that the distance between A and B plus the distance between B and C is going to be 5 square roots of 2, right? Okay, so let's go ahead and find the distance between A and C. Okay, so this will be the distance between the point. So A was the point 1 comma 1 plus D, 1 comma 1 plus D, And C was the point 6, comma 6 plus D, right? Let me make sure. 6 comma 6 plus D. Okay, so this is equal to, so the square root. So this will be 1 minus 6 squared, right? 1 minus 6. And then plus 1 plus D minus 6 plus D squared. And this is going to be the square root. So this will be -5 here, -5 squared. And then the d's will cancel, and we're left with 1 minus 6. So this will be -5 squared as well. And then this is equal to the square root of 25 plus 25, which is equal to the square root of 50, which we can reduce this to the square root of 25 times the square root of 2, which is, of course, equal to 5 square roots of 2. So we got it, right? So the distance between A and B plus the distance between B and C is equal to, so the distance between A and B we found to be 2 square roots of 2, right? 2 square roots of 2. And we found the distance between B and C to be 3 square roots of 2, right? Which is equal to 5 square roots of 2, which we found to be the distance between A and C, right? So this is the distance between A and C. So this means we have the distance between A and B plus the distance between B and C is equal to the distance between A and C. So by the segment addition postulate, this means that A, B, and C are collinear. And that's what we set out to do. That is the proof.